Problem 4. A particle moves along the x-axis so that its velocity at time t for 0 to 6 is given by a differentiable function v whose graph is shown above. The velocity is 0 at t equals 0, t equals 3, and t equals 5, and the graph has horizontal tangents at t equals 1 and t equals 4. The areas of the regions bounded by the t-axis and the graph of v on the intervals 0 to 3, 3 to 5, and 5 to 6 are 8, 3, and 2, respectively. At time t equals 0, the particle is at x equals -2. Before I even go through and read the question, I'm going to do a little bit of labeling here. It told me that the areas of the regions from 0 to 3, they said this was 8. They said, that's the area. They said the area from 3 to 5 was 3. And then they said the area from 5 to 6 is 2. So I'm just going to put that in there so I don't forget about it later. Okay, part A, it says for 0 to 6, find both the time and the position of the particle when the particle is farthest to the left. So if I'm moving to the left, that's going to be talking about velocity. I need to really figure out, and that's almost like an absolute minimum, I'm going to probably call it, because if that's an absolute minimum, I'm farthest to the left. All right, and there's a couple different ways that I'm going to look at this problem, and you can look at which one makes the most sense to you. Alrighty, first of all, if I'm looking for a minimum at all, I'm going to be looking for critical numbers. So I'm going to figure out where does my velocity equal 0. My velocity equals 0 at 0, 3, and 5. So I'm going to find velocity equals 0 at t equals 0, 3, and 5. So if you recall, usually when we do this, we're going to be finding the position. So go back to position. We want to find it at 0, at 3, at 5, and then we do need to find it at 6 because that's another endpoint. Okay, the position at 0, they actually told us. They told us at time equals 0, the particle is at x equals -2. Right? Now, if I want to figure out what's happening at x of 3, first of all, the particle was at -2, so we have to remember that. And then if I'm going to go from 0 to 3, so it's actually going to be plus the area under the curve from 0 to 3 of the velocity. So to get from 0 to 3, you'll notice that area was 8, and it's underneath the x-axis. So this will be actually -2 plus -8, which gives me -10. And then x of 5, we're already at -10, so we're at 3. Now I'm going to find the area under the curve from 3 to 5 of the velocity. So this will give me -10 plus that area was 3 and it's above the x-axis. So that's -7. So now the particle's at -7. And so now I'm at -7. Now I just need to travel from 5 to 6. And so this will be -7. And then since this 2 is below the x-axis, it will be -2. So the particle is now at -9. So it says, when was the particle furthest to the left? That would probably be when the particle was at -10. So that occurred. So I would say the particle was farthest to the left at t equals 3. And it said the position. So now I'll say the position is x equals -10, right? And I justified my answer whenever we're finding an absolute. That is totally justified. All right, another way, let me give you the points for this. This was worth 3 points. If we would have found the t equals 3, so you consider t equals 3, which we did, we would get a point, okay? If we found the integral from 0 to 6, which we did, which was -9, we got a point for that because we did have to consider that endpoint. And then when we described, and then it just says the conclusion. So I did get the conclusion correctly in this one. Another way we might have been able to think about this one is we could have thought about the particle. We know that the particle was at -2, then it moved to the left 8, it moved to the right 3, and then it moved to the left 2. So that is another way that you could kind of think about that. All right, for how many values of t, where t is between 0 and 6, is the particle at x equals -8? Okay, on this one, I'm definitely going to do some thinking on it. Right, I'm going to draw myself a little number line here. All right, we know the particle starts at -2, so I'm going to put 0 on here. The particle starts Okay, the particle starts at -2. So this is where the particle is right now. Okay, what's going to be happening to this particle from 0 to, so it starts at -2. From 0 to 3, the particle ends up going to the left 8 because the area under the curve is negative. So if I go to the left 8, notice I'm now at -10. Okay, and then from 3 to 5, my velocity is positive, which means I'm now going to turn around and go right 3 units, which is going to bring me to the -7. And then I'm going to go, my last one, I'm going to go back to the left 2 spots. So I'm going to end up back at -9. Okay, so the question on this one, so that's kind of just the particle's motion, even though it's just really along one axis. I moved it up a few notches just so that you can see what's going on. So this said, for how many values of t is the particle at x equals -8? So -8 is right here. So you'll notice there's 1, 2, 3 times where the particle was at x equals -8. Okay, so there are 3 times. Explaining my reasoning, basically what I'm going to say is the particle traveled from -2 to -10, then from -10 to -7, then from -7 to -9. And then in order to get from -2 to -10, you have to pass through -8. In order to get from -10 to -7, you have to pass through -8. And in order to get from -7 to -9, you have to pass through -9. -8, excuse me. The theorem that would go along with that would be the intermediate value theorem. So I'm just going to put the intermediate value theorem. Justifies me the particle passing through -8 3 times. Okay, and you could have worded it a little bit differently, but you should have kind of the same thing going on there. So we need to define the position at t equals 3, t equals 5, and t equals 6. We already did that in a previous part. And so I would get a point for that. I'd next get a point for the motion. I did talk about the motion. I said the traveled from x equals -2 to x. I should actually put maybe x equals -2. That should make sure I get my points on this one. I was talking about the motion. I was saying which way it traveled. And then I might have even said the particle traveled from, I might have said traveled left from -2 to -8, then right, and then left, just to be a little bit more specific, just in case. But I did describe the motion, so I'm going to get a point for that. And then I do have a justification. So the intermediate value of the theorem was my justification. Alrighty, part C. All right, on the interval from 2 to 3, is the speed of the particle increasing or decreasing? Okay, if you'll recall, the speed of the particle has to do with the velocity and the acceleration, and we need to figure out what the velocity and the acceleration are doing. So I am going to make a velocity chart first of all. Okay, if I'm doing a velocity chart, this is velocity, so I'm just going to be looking at where it hits, which is going to be 0, 3, and 5. I notice that I'm below the x-axis, so my velocity is negative until 3. Between 3 and 5, my velocity is above the x-axis, so velocity is positive. And then after 5, I'm below the x-axis, so my velocity is negative. Right? I next need an acceleration chart. So if I do an acceleration chart, since the acceleration is the derivative of velocity, we're going down a level, we'll look at the slopes. So the slopes are negative till I get to 1. 1, negative till I get to 1, that is a 1. And then they are positive all the way till I get up to 4. And then they are negative after that. All right, so if I'm looking at on the interval from 2 to 3, 2 to 3 would be right in this area right here. So I notice my velocity is negative. And then 2 to 3 on this one would be right in this area, so my acceleration is negative. So since my velocity is negative and my acceleration is positive, they're different signs, which means they are working against each other, so the speed of the particle will decrease. So I will say the speed of the particle is decreasing because velocity and acceleration are opposite signs. Okay, that's really all I need to say about it. All right, that was worth just 1 point. You either got it or you didn't. Okay, during what intervals for part D is the acceleration of the particle negative? Well, we've already done an acceleration chart, so I can see the acceleration is negative right here and right here. So the intervals would just be 0 to 1 and 4 to, looks like we're going to 6. And of course we need a statement or need a justification, and that will be because during which is the acceleration of the particle negative. Oh, okay. I really don't know what I'm going to say on this one. The acceleration of the particle was negative. I guess we could say because velocity was decreasing, or the slopes of the velocity were decreasing. So anything about that, the slopes of the velocity were negative, something about that, we would be okay. That was worth 2 points. So if you got 1 point for your answer, 1 point for your justification. We definitely wouldn't say 0 to 1 and 4 to 6 because acceleration is negative, because that was the question we were supposed to answer. So we do want to somehow refer back to the velocity chart.